Picture the entire universe shrunk down small enough to sit on a table in front of you. Would it look smooth, like a marble? Or would it look lumpy, uneven, like a handful of gravel thrown across the surface? For most of the last century, the people who study the cosmos for a living have bet heavily on smooth. Not perfectly smooth up close, nobody thinks that galaxies clump together and there are enormous empty gaps between them. But zoom out far enough, the thinking goes, and eventually all those clumps and gaps average out into the same thing everywhere you look. So here's a question worth sitting with for a second. What happens if something out there refuses to follow that rule? That idea that the universe looks basically the same, no matter where you stand or which direction you face, is not just a nice guess. It is one of the load-bearing walls of modern cosmology, quietly holding up almost every calculation about how old the universe is, how fast it is expanding, and where it is headed next. Pull that wall out, even a little, and a lot of very confident numbers start to wobble. Scientists have a rough rule of thumb for where that smoothness is supposed to kick in. Somewhere around 1 billion light-years across, give or take. The universe is supposed to stop caring about local clumps and just look like an average soup of matter, no matter which patch of sky you are staring at. Think of it like zooming into a pot of soup. Get close enough and you see individual chunks of vegetable, all different. Pull back far enough and it just reads as soup, evenly mixed, no matter which spoonful you scoop. That is what the universe is supposed to do on the largest scales. And for the most part, when astronomers have checked, it does. Except for a small, stubborn pile of exceptions that keep showing up exactly where they should not. Every decade or so since the late 1980s, someone has announced a structure so big that, on paper, it should not be possible. A wall of galaxies here, an arc of matter there, each one bigger than the last, each one reigniting the same argument all over again. And almost every single time, the finding gets picked apart, argued over, and often waved away as an illusion hiding inside messy data. Which is a completely fair reaction, honestly, because it is shockingly easy to convince yourself you have found something that was never really there. Have you ever stared up at clouds and suddenly seen a shape in them? A face, an animal, a dragon, something that felt completely obvious in the moment? Your brain is extremely good at finding patterns, so good that it will happily find them in places where no real pattern exists. Scientists have exactly the same problem, just with data instead of clouds. If you search through a big enough pile of random data looking for a shape, you will eventually find one that looks convincing, purely by accident. It is a little like buying enough lottery tickets that one of them is bound to have a lucky-looking number on it. That trap has a name in the scientific world, something researchers call the look elsewhere effect. And it is the single biggest reason a claim about a giant cosmic structure gets treated with suspicion first and excitement second. So the moment somebody claims to have spotted a shape hundreds of millions of light-years wide, the very first question every other scientist asks is simple. Did you actually find something, or did you just stare at cosmic clouds long enough to see a dragon? Keep that skepticism in your back pocket, because it matters a lot for where this story is going. To even attempt mapping matter across an enormous stretch of sky in the first place, researchers reached for some of the most extreme objects the universe has to offer, blazing, distant beacons called quasars. A quasar is powered by a black hole so massive and so hungry that the matter swirling into it heats up and outshines an entire galaxy from billions of light-years away. Think of each one as a flashlight shining across most of the observable universe, aimed straight at us. Along the way, that light passes through faint clouds of gas drifting near far-off galaxies, gas so dim that ordinary telescopes could never photograph it directly. But that gas leaves a fingerprint. It absorbs one very specific, recognizable sliver of the quasar's light, based on the chemistry sitting inside the cloud. Read thousands of those fingerprints, scattered across the sky at the same rough cosmic distance, and you can quietly reconstruct where matter is clustering, even in regions too dim and too vast to ever photograph the normal way. It is a bit like mapping an invisible crowd by listening for thousands of individual footsteps instead of trying to take one giant photograph of everyone at once. If the idea of scientists hunting for cracks in one of cosmology's biggest assumptions, using nothing but the flicker of ancient light, is the kind of thing that grabs you, this channel digs up a new one of these stories every single week, so go ahead and hit subscribe while you are here. Now, back to that footprint method, because it is about to turn up something nobody was fully expecting. A few years ago, using exactly this technique, researchers stumbled onto an arc of matter so large it stretched across roughly 1 billion light-years of sky. Not long after, in practically the same patch of sky, a second oddity turned up. A ring-shaped filament of matter, big enough to make the first discovery look almost modest by comparison. Two enormous, unexplained structures sitting almost on top of each other, at the same staggering distance from Earth. Is that just an accident of where humans happen to point their instruments? Or is it a clue that something is going on that the tidy, smooth model of the universe does not fully account for? If it turns out the universe genuinely is not smooth at the scale everyone assumed, that is not just an academic curiosity. It would ripple into how we calculate the universe's age, how fast it is really expanding, and whether some of our best models need a rewrite. That is exactly where the newest chapter of this story picks up. So what if that stray arc pointing north was not a coincidence at all, but a signpost towards something even bigger, still hiding in the data? Before a third structure was even confirmed, researchers had already guessed roughly where it should be, based on a smaller, partial arc of matter that seemed to be pointing the way, like a broken piece of a much bigger shape. It looked like it might connect the first two oddities into one single, enormous loop. When they went back with newer, more sensitive data, that loop showed up almost exactly where the predictions said it would. A ring on the sky, roughly 1,300,000,000 light-years across, sitting in a slice of the universe so far away that its light left home when the universe was still roughly half its current age. A prediction lining up with an observation is a good start, but on its own it is not enough. Remember the cloud shapes. So the team ran the numbers two completely different ways before trusting any of it. First, they tested how well a ring actually fit the pattern of matter in the data, and found not one but two overlapping versions of the shape that fit far better than random chance should allow, clearing a bar well beyond what is normally required to call something a real detection instead of noise. Second, and more importantly, they ran a completely separate kind of test, one that looks at clustering across the whole patch of sky at once, instead of hunting for one particular shape. That second test also came back positive, picking up real, significant clumping on a scale of roughly 1 billion light-years, using a method that is much harder to fool with an accidental pattern. Here is the part that actually makes this convincing, instead of just interesting. The team tested their exact methods against random, fake data built to resemble their real field, and separately against one of the most detailed simulated universes ever built inside a computer, running under the same standard rules cosmologists already trust. The simple shade matching test did get fooled sometimes, finding convincing-looking rings inside random noise, exactly as the look elsewhere warning predicts. But the second, stricter test told a very different story. Across every single one of those fake and simulated skies, none of them produced the kind of large-scale clustering seen in the real data. The fakes looked like noise, the real sky did not. Which brings us back to that earlier coincidence. This is now the third unusually large structure researchers have turned up in this exact same patch of sky, at this exact same staggering distance. One strange structure could be a fluke. Two, sitting almost on top of each other, starts to raise eyebrows. Three, nested together in the same small volume of space, is much harder to wave away as one-off noise because the odds of that much coincidence keep shrinking every time it happens again in the same place. And here is the honest part, worth remembering before getting carried away. None of this proves that our basic picture of the universe is wrong. The two earlier structures already drew public pushback from other scientists, who argued similar-looking shapes can turn up naturally inside standard simulations if you are not careful about how you search. The researchers behind this newest ring describe it themselves as a preliminary result, not a final verdict, and openly admit that a visually striking pattern is never automatically proof of something real. What keeps this particular case alive is simple. The very same simulations built to challenge findings like this one still could not reproduce what shows up in the real sky, no matter how many times they tried. So is the universe actually as uniform as the textbooks assume? Or are there rare, enormous seams in it that current models simply were not built to explain? Nobody can say for certain yet, but somewhere out there, a billion light-year ring is quietly waiting for someone to prove it wrong, or to find the next one right beside it,